Hi viewers, today we're going to see real numbers exercise 1D. This is for grade 10 CBSE board. Question 1 is define rational, irrational and real number. So rational number is nothing but a number of form P by Q. Where P and Q both are integers and Q is not equal to 0. Next, we have to see irrational numbers. We can see some examples for rational. Anything of fractional form, numerator by denominator forms, and the denominator is not equal to 0, then they are rational numbers, even negative, because it's mentioned as integers. Next, irrational numbers are the numbers which can be represented as in decimal forms, and they are usually non-terminating and non-repeating numbers. Non-terminating, it's not ending up, it continues. And non-repeating, the pattern is not repeated, it just goes on. We can take the square root of 2, 3, 7. Even the value of pi are the examples of irrational numbers. Next, the real numbers are the combination of both rational and irrational numbers. It can be of form 2 plus square root of 3, 2 minus square root of 5. So it can be of combination of both rational and irrational number. So question 2 is classify as rational or irrational number with a given list. So first one is of the form fraction, so they are rational number. Second one is 3.1416. This is again rational number because it's terminating after 6. One is value of pi. This is irrational because it's non-repeating and non-terminating. Fourth one is again rational because it's not terminating and repeated. The numbers are repeated, so it is rational number. Non-terminating, repeating numbers. Same way for question 5, if you see, it's non-terminating and also repeating. The numbers are repeated, 63, 63, 63. So this is again a rational. Next question 6, 2.040004. It's again non-terminating and it's a non-repeating. If you see 04, then 004. So it's not repeating. So this is irrational number. Non-repeating, non-terminating are irrational numbers. Next question 7, again if you see, it's non-terminating and non-repeating pattern of numbers. So irrational again. Next is question 8, non-terminating and non-repeating pattern. This is again irrational. Next is square root of 21 can be written as 3 into 7. So, which means 3 and 7 are prime numbers, and again they are irrational. Question 10 is again irrational. 3 is a prime number. If it's a perfect square, then they are rational numbers. Square root of 4 is 2, so rational. Square root of 9 is 3. Square root of 16 is 4. So all these are rational numbers, whereas they are prime numbers. So square root of the prime numbers, they are irrational. Question 3, prove each of the following number is irrational. So here it's the other way. So square root of 6 is written as square root of 2 into square root of 3, and we know product of two rational numbers is again a rational number. So this is obviously irrational. Next one is 2 minus square root of 3, which we can subtract with minus 2. So 2 and 2 goes off, and square root of 3 is not rational, and we know difference of two rational number is again a rational number. So which contradicts this, as root square root of 3 is irrational, so hence proved this number is irrational. Next again 3 plus square root of 2, we can subtract it by 3. So 3 and 3 goes off, and 2, and we know the difference of two rational is again rational, which is not the case. Same with question 4 again, subtracted by 2, you get a square root of 5. So this difference is not a rational number, obviously. Hence proves this number is an irrational number. Next, question 5, we need to subtract it by 5. So 5 and 5 will go off. The remaining is not a rational. So obviously, this is the irrational number. Question 6, 3 into square root of 7. We know product of two rational number. If we assume 3 and square root of 7 as rational, product is again a rational number, which is not the case here, as 3 is rational and square root of 7 is not rational. So this proves this number is irrational. Next question 7, 3 by square root of 5. We can multiply and divide it by the denominator. So we get 3 square root of 5 by 5, which can be written further as 3 by 5 into square root of 5. So square root of 5 is irrational. 3 by 5 is of a fractional form, but square root of 5 is not a rational number. This proves that number itself is irrational. Next question 8, we need to subtract it by 2. So 2 and 2 goes off, and the difference of two rational is rational, which is contradicting. So hence prove this is a irrational number. We know sum, difference, product, all of two rational number is always a rational number. Next question 9, square root of 3 plus square root of 5. If we assume both are rational numbers, then the square of the same is also a rational number. So we can try to do the square of it. Square root of 3 plus square root of 5 whole square. So that is a plus b whole square. It's a form. So we need to expand. A square is 3. B square is 5. 2ab is 2 into 5 3s are 15. Square root of 15. So 3 plus 5 is 8, plus 2 square root of 15 minus 8. 8 and 8 goes off. So the difference, if we assume both are rational, answer also should be rational, which is not the case. Hence prove this is a irrational number, which contradicts if we assume both are rational numbers at the beginning. So this proves that the given number square root of 3 plus 5 is irrational. Question 4, prove 1 by square root of 3 is irrational. So you can just multiply and divide by square root of 3. That becomes square root of 3 by 3. Square root of 3 into square root of 3 is 3. which can be written further as 1 by 3 into square root of 3. Product of two rational number, if we assume both are rational, the answer should be rational, which is not the case as the product has irrational number. So hence prove the given number 1 by square root of 3 is irrational. Next, question 5, first part is give an example of two irrational numbers whose sum is rational. So we can assume two numbers. It could be, let us assume it has 1 plus square root of 2 and 1 minus square root of 2. So when we sum this up, because we are saying sum, so addition, these two are irrational numbers. When we sum it up, minus 2 square root and plus 2 square root goes off, and the answer is 2, which is a rational number. Same way, second part is we need to give an example such a way product of those two irrational is rational. Here again, let's assume two numbers, any two numbers or two irrational numbers. I'm taking your 5 plus square root of 2, 5 minus square root of 2. So it's of form a plus b and a minus b. So a plus b into a minus b is, since it's a product, I'm doing multiplication. So a square minus b square. So 5 squared is 25. Square root of 2 whole squared is 2. So 25 minus 2 is 23, which is a rational number. Hence, this is the example. You can give any number, any two irrational product. Question 6, state whether true or false. Sum of two rational numbers is always rational. Yes, it is true. Let's assume 2 plus 3 is 5. 2 and 3 are the two rational numbers. Product of two rational numbers is always rational. Yes, true. So 2 into 3 is 6. Question 3, sum of two irrational is always irrational. This is false. Contradicts to our previous question 5 itself. Product of irrational is always irrational is also false, which is already illustrated in question 5. Then question 5 in 6 is sum of irrational and irrational is always irrational. That's true. Product of rational and irrational is again irrational. That is also true. But for question 3 and 4, we already illustrated in question 5 the same thing. Two irrational numbers, when we sum up, it can also give rational number. Same way, product of two irrational numbers can also give a rational number as a output result. I'm just taking the same example taken in question 5, but you can take any number to understand. Two irrational numbers can also give the resultant rational. I believe it's clear. So it's not necessary to be always irrational. Question 7, prove 2 square root of 3 minus 1 is irrational. So let us just assume this is a rational number, the given number in the question, and then we add 1 to this. So 1 and 1 goes off. So it becomes 2 square root of 3. Sum of rational is always rational. So obviously this is not giving the answer that way. So 2 square root of 3, if you see again, as a product of two rational number, considering 2 and square root of 3 as rational, that's again not satisfied because square root of 3 is not rational number. So this proves the question 2 square root of 3 minus 1 is irrational number, hence proved. Remaining questions are of very similar pattern. Hope this is useful. Thank you.